Alright, so continuing with composing functions, given that we have f of x equals x squared minus 3x minus 2, and that g of x equals x plus 5, what are we going to get? Now, this is not fog, okay? This is f of g of x. Notice how we can write it this way or this way, and they say and mean the same thing, f of g of x or f of g of x. So when you see an open circle, you know that it's not fog, but it's not multiplication. It is a composition of functions, so f of g of x. So let's go ahead and find this. What we're going to do is look for our innermost function. So g of x is our input, and our output, our outermost function, is going to be f of x. So everywhere I have an x in f of x, I'm going to take and substitute our value of g of x. So here I have two different terms that have a variable of x in it. So I'm going to take my g of x, which is x plus 5, and I'm going to replace everywhere I have an x in my output, my f of x, my outermost function, with my g of x, my innermost function, which is x plus 5. So instead of x squared, what I actually get is x plus 5 squared. And then instead of minus 3 times x, I get minus 3 times x plus 5. So I've replaced everywhere I had an x in f of x with my entire function g of x. Don't forget the minus 2 down here at the bottom. And so really, that was the hard part. The easy part is trying to simplify this. Now, there is a shortcut that you could use for this. A common mistake people make is they say x squared plus 25. I'm going to go ahead and use the shortcut. If you are not comfortable with the shortcut, that's okay. You can write this as x plus 5 times x plus 5, and you can go through the distributive property. So how you use the shortcut properly is that you're going to take the first term and square it. So x squared. Everyone's like, yeah, I know how to do that. But where most people forget is you multiply the two terms together. So x times 5 is 5x, and you double it. So we're going to get 10x, and that's positive, so plus 10x. And then you square the last term. So 5 squared is 25. Most people will get these first and last terms correctly, but they forget about that middle term. And you see it a little more easier if you were to write it out, x plus 5 times x plus 5, and distribute. Finally, we have this negative 3 being distributed to each term on the inside of the second set of parentheses. So negative 3 times x is a negative 3x. Negative 3 times 5 would give us negative 15, and we still have that minus 2 out here on the end. Now, amongst all of our terms, we have 6 terms here. We're just looking for like terms. I don't have any other x squared, so I'm going to bring that straight down. I do have a 10x here and a negative 3x. So just reading from left to right, 10 minus 3 is going to give me 7, so that's positive, so plus 7x. And then finally, I have this positive 25 minus 15, which is going to be 10, minus another 2, which is going to be 8. So 25 minus 15 is 10, minus 2 is 8. And that is positive, so plus 8. So that is our answer for composing f of g of x. So as I pointed out, this is actually asking us to do the same thing. Find f of g of x. So even though it looks different, I want you to get used to seeing both ways that it can be written. Now, the other extra thing that we're going to do for these next two problems is also write the domain. So here we have no domain restrictions. This is a quadratic, it's a parabola that opens up, and so our domain would be all real numbers. But we're going to have domain restrictions here. So let's go ahead and compose. So f of g of x. So everywhere in my input, my innermost function, g of x, I'm going to replace x minus 1 with x in everywhere I have an f of x. So instead of the square root of 3x plus 15, I really have the square root of 3 times g of x, which is x minus 1, plus 15. Now just simplifying under here, not a big deal. We're going to take this 3 and we're going to distribute that underneath the radical to every term on the inside of the parentheses. So I have the square root of 3x minus 3 plus 15. Now because these terms are underneath the square root, we can go ahead and combine them. They are like terms. So I have the square root of 3x plus 12. And all of that is under the radical. Now, this is the correct answer. That is our answer. So this is f of g of x. Now we need to find our domain restrictions. So you might be saying to me, well, how do I do that with radicals? Well, what kind of numbers cannot be under a square root? And I hear you right now. You're saying negative. Yes, don't be a negative Nancy. You can't have any negative numbers underneath the square root. So how we find what our domain is, our domain has to be all possible x values that are greater than 0, because any number less than 0 is going to be negative. So I need all the x values that are greater than or larger than 0, and that is going to tell us what our domain is. So once I solve this inequality, then I'll have our domain. So we're going to subtract 12 from both sides first. So I get that 3x is greater than negative 12. And then from here, I'm going to divide both sides by 3. So after I do that, I get that x is greater than a negative 4. What this is saying is that my domain is all of the x values that are greater than negative 4, because if I have a number that's less than negative 4, that's going to give me a negative value underneath the square root, and I cannot have negatives under a radical. So let's go ahead and take a look at number 3. We're going to have a little bit of a different type of situation here with our third problem. So now we're using different function titles or names, but we have g of x and h of x. And what we want to do is find g of h of x. So our input, our innermost function, is 2x minus 9. And again, I have two places that I'm going to substitute that into our outermost function, g of x. So let's go ahead and see what this looks like. So instead of x plus 2, it's really 2x minus 9, this entire h of x function, and then plus 2. Over, instead of instead of x plus 3, I'm going to replace that with 2x minus 9, and then plus 3. So yeah, that's a very interesting equation or composition of functions here. But let's just combine alike terms. So what is a negative 9 plus a 2 and a negative 9 plus a 3? So our new numerator is going to be 2x minus 7, and our denominator is going to be 2x minus 6. So after we combine like terms, this is it. This is our answer. Now, the other issue that we have here is we wrote this domain in inequality form. I want to write this domain in interval notation, so I'll show you what that means here in a moment. This is our answer. This is the composition of functions g of f of x, but we have a domain restriction here. So underneath the square root, we weren't allowed to have negative numbers. But what about in the bottom of a fraction? What can you not have in the denominator? Well, you cannot have 0 in the denominator. So I'm going to go ahead and write this right here. So I'm going to take that denominator, this 2x minus 6, and I'm going to set it equal to 0. So whatever value I get for our denominator that would give me a value of x that equals 0, that is going to be my domain restriction. That's going to be the value that I cannot have. So after I solve this, if I add 6 to both sides, I get 2x equals 6. And after I divide by 2, I get that x equals 3. And so what we're saying is that x cannot equal 3. Now you may have some teachers that say you can write this as, oh, our domain is all real numbers from negative infinity to positive infinity, but it cannot be equal to 3. And I think that's okay. You might see it like that. However, in interval notation, it looks a little different. So I want to show you why this looks different. Interval notation, we're going to say I can have all my numbers from negative infinity, comma, really to positive infinity, but all the way up to 3. So negative infinity to 3, but it can't be equal to 3. So I have to use a parenthesis. And then I need another set to say from 3 to positive infinity. So what we're going to do is we're going to use what's called union. So this weird looking U or parabola symbol, that means or. So in math, this symbol means or. Or our values are going to be from 3, comma, to positive infinity. So we're saying that our domain are all the values from negative infinity up to 3, where there is an asymptote at 3, or from 3 all the way up to positive infinity. So I don't know if you've ever seen that before. I wanted to show that to you because you may see that on maybe an ACT test or another state standardized test.